लाइफ हो आउट ऑफ कंट्रोल, होठों को करके गोल, होठों को करके गोल, सीटी बजा के बोल। लाइफ हो आउट ऑफ कंट्रोल, होठों को करके गोल, होठों को करके गोल, सीटी बजा के बोल। मुर्गी क्या जाने अंडे का क्या होगा, हर लाइफ मिलेगी या तवे पे फ्राई होगा, कोई न जाने अपना फ्यूचर क्या होगा। होठ घुमाओ, सीढ़ी बजा के बोल भैया ऑरेंज मैन, अरे भैया ऑरेंज मैन, अरे चाचू।
Hi guys, I am James Constantino Vival. I will teach you Bernoulli's principle and we will also solve some problems of this. So first, let's see the course outcomes that you will learn after this video. Number 1, you will learn how to explain the basic principles and components of Bernoulli's equation. Number 2, at the end of this subject, you will understand the principle of Bernoulli's equation. Number 3. You will learn how to analyze Bernoulli problems. Number 4. You will learn how to apply it on different kinds of problems. So now we will solve some problems so that you could understand it. In this problem, we will solve number 1. How fast will water flow out of the tank if the storage tank is open at the atmosphere sea level? So first, we need to analyze the picture. And then, we have a given of 20 meters, that is the height. And then, we have a constant gravity of 9.81. So, we will just substitute that to the formula. This is the formula. P squared is equals to 2 times gravity, that is 9.81 meter per second times the height. So v squared has a number 2 here, so we'll square root both sides to cancel that. So now the final answer would be 19.81 meter per second. This is the answer. And now I will teach you where this formula came from. Imagine if you have an object here. If you're holding an object and it has a height of 20 meters. If you're holding it, it has a potential energy. If you stop holding it, it will drop. That is potential energy. After that, it will fall and it will roll. That is the kinetic energy. So in here, we have potential energy is equals to kinetic energy. So if you remember, we will transfer the values of kinetic energy and potential energy, where potential energy is mass times gravity times height, and kinetic energy is 1/2 mass times velocity squared. So now we have a mass here, we will just cancel this out. And then we will use number 2 to multiply both sides. It will also cancel this 1/2. So now we have this formula. So now this is the formula. That is where it came from. You now know how to derive it. In this second problem, I will teach you how to solve or derive that formula using different method. We will use the Bernoulli's equation. So this is the problem right here. It is a tank that is open to atmosphere. So here in point A, this is point A, and this is point B. Here in point A, we have a atomic pressure of 1. And also here in point B, we have a atomic pressure of 1. So we'll just cancel this out. And also here in point A, the velocity is very slow. It is coming down. So when it is very slow, we will assume that it is 0 because it is very slow. So we'll just cancel this out. And then here in point B, the height is 0. In point A, the height is 20 meters. So now, here in point B, we'll cancel this out. And then, we are left with this. Now we have the same density because we will just use the fluid. So we'll still cancel this out. Cancel this one, I mean this one. Now we are left with this. So now we will multiply both sides using number 2. This will be cancelled out. So now we have a formula. This is what is left. To understand more of that problem, here we have the P1. P1 here is the static pressure of the fluid at the cross-sectional. This one is the density of the flowing fluid. V1, it is the velocity of the fluid at the cross-section. H is the height or the elevation of the object where the fluid will be put. In this one, continuity and compressibility, most gases are easily compressible, most liquids are not. Therefore, the density of a fluid may be treated as constant, not true for a gas. Here, this is the continuity equation or mass flow conserved. This means that what comes in must also equal to what must come out. Like the problem that we solved, earlier. Equation of continuity for an incompressible fluid. A1 V1 equals to A2 V2. This is volume flow is conserved. So that is all, guys. Thank you. I hope you learn a lot. See you in my next video.
So hi to everyone. I'm going to provide an example of Bernoulli equation and teach you how to solve some simple steps so that you will be able to understand more about the Bernoulli problems. A piezometer and a pitot tube are tapped into a horizontal water pipe as shown in the figure. To measure static and stagnation, static plus dynamic pressures for the indicated water column heights, determine the velocity at the center of the pipe. So we have been given 3 heights So we have height over here in the bottom, 3 centimeter. Yeah, 3 centimeter. So at the center, we have also 7 centimeter, and at the top is 12 centimeter. So we have a water flow over here at the right. So we have this the velocity, and then another point here is stagnation point. So this is known as piezometer. This is a piezometer, and then the other one is a pitot tube. So this is a pitot tube. So our given, we have already been given in the figure. So our findings would be to determine the velocity at the center of the pipe. So the process of answering this solution would be this. Since we have given the 3 heights, so our analysis is this. So our point, so we need to take point 1 and 2 along the center line of the pipe, with point 1 directly under the piezometer. So this is the point 1, directly under the piezometer. And the point 2 at the tip of the pitot tube, including the bottom. So our point 1, H1 plus H2, and our point 2 is H1 plus H2 plus H3. So this is our point 1. So our point 2 is H1 plus H2 plus H3. This is our point 2. And so our analysis is this. Point 1 equals PG H1 plus H2, and point 2 H1 plus H2 plus H3. Since our solution is to determine the velocity at the center of the pipe, and then we consider the point 2 is a stagnation point, and thus the velocity over there is equals to 0, and as usual the Z1 is equals to Z2, so or H1 equals H2. So our solution is the application of the Bernoulli equation between points 1 and 2 gives this. So this is the general equation formula, common formula. We can also express this into another form. So P1, PG plus velocity squared 2G plus H1 equals the 0.2 over PG plus V2 over 2G squared plus H2. So we can cancel out the H1 and H2. And then since the point 2 is stagnation point, we will also cancel this out. We don't need this because the point 2 is a stagnation point. So next would be P1 squared 2G equals P2 over PG. So we will just transpose the P1 in the right. That will be this. Since they are the same in the bottom denominator, P1 squared over 2G, P2 minus P1 over PG. So we will just substitute our analysis before, the H1 plus H2 plus H3. So substituting the P1 and P2, we have this. So PG, H1 plus H2 plus H3. This is the P2 tube in the bottom, and as well as minus PG, H1 plus H2 only, since we only determine at the center of the pipe, over PG. So getting everything. So we have PGH1 plus PGH2 plus PGH3 minus PGH1 minus PGH2. So we'll just cancel out that PGH1 and PGH1, as well as the PGH2 and the PGH minus PGH2. So we will also cancel out the PG and the PG in the bottom. So the remaining na lang dyan is the H3. So V1 squared over 2G equals H3. So transferring the 2G to the right. So we will have this. Yan. So V1 equals square root 2G H3. Yan. So inserting or plug in. So we already know that the gravity is 9.81 meter per second. So noting that 12 centimeter is 0.12 meter. So our height is 0.12 meter to match the gravity, which is the meter. So if we will consider centimeter, we might also consider converting the units. So the answer of this, of the velocity, is 1.53 meter. So we accomplished finding the velocity. So this is a form of an example of Bernoulli equation. So I hope everyone understands this kind of method.
Good day, I'm Dexter Lloyd Corhio. I'm part of the group of Bibal, Fuldan, Madronero, Montibon, and Picar. Today we will have an example for Bernoulli's equation. We have a tank here, an open tank, which is exposed in atmosphere. Okay, let's get started. We have an equation here for the Bernoulli's, which denotes as pressure 1 plus rho gh1 plus 1 half rho v squared, which is our velocity for point 1, and pressure 2 plus rho gh and a height for point 2 plus 1 half rho v squared rho v2 squared, which is our velocity for point 2. First, we have to identify the points. Here we have point 1 and here we have the point 2. The the pressure in the point 1 is atmospheric because it is exposed in atmosphere, and also in the point 2 because when the water comes out in this outlet, it will be exposed in air, so it will be an atmospheric pressure. And here we have the velocity. The velocity for point 1 is 0. Why is that so? Because we have here a tank. This tank is big and the outlet is so small. So the velocity of the tank when the water comes out in this outlet is very slow. So we should assume it as 0. And also here we have the height. The height here is equal to 0 also because our height in point 2 is our reference point, so it should be 0. And okay, then here pressure 1, pressure 2, it should be cancelled, and here it should be 0. Also here it should be 0. So that what remains here is rho gh1 equals 1 half rho v2 squared. So arranging the equation, we get the answer here. This is the velocity for the outlet here. This is the velocity here. That's all. Thank you.
So, hello everyone. My name is Japit Jones G. Fuldan. I am third year BS Electrical Engineering, studied in University of Mindanao. So I'm here to solve one problem of Bernoulli's equation and mechanics of fluids. So let's start. So the problem given is number 1. Water flows through a circular pipe with a constant radius of 10 centimeter. The speed and pressure at point A is 4 meter per second and 250,000 Pascal respectively. So the problem of this question is what is the speed of the fluid at point B? And the other one, what is the pressure at point B, which is 10 meter higher than point A? So let's say this is our figure, and in the left side we have point A tube, and the right side is point B tube. And from point A to point B, there are 10-meter apart. So can say also that from the ground to point B, there is 10-meter difference height. So to solve the A, we know that the velocity 1 of the point A is 4 meter per second, and the area of the point A is 10 centimeter or 0.1 meter squared. So can say that V1 A and times A1 is equals to V2 equals A2. So in this equation, we have the V1 given, A1 given, and the velocity 2 is missing, and the A2 is given because it says in the statement in the problem that circular pipe with a constant radius of 10 centimeters. So it means from A, from radius A, from to radius B, the area is still the same. So we can plug in the given, and this is it. The velocity is 4 meters squared per 4 meter per second, and times 0.1 meter squared. We convert the 10 centimeter into meter and equals to V2, which is the missing, and area 2, which is 0.1 meter squared. So when we calculate this, the answer would be, I think you know it's already, it's 4 meter per second, because logically we can see it from our eyes that the velocity flows in the tube A would be still the same from the tube B, because take note that the call this the area of the tube A is still the same in the tube B. Take note that the velocity only change when the area of the tube is resized. So we know that the velocity increase when the area decrease, and the area increase, the velocity decrease. So that's the principle of the Bernoullis. So to letter B, what is the pressure at B, which is 10 meter higher than point A? So we know that the formula of the Bernoullis equation is this: pressure 1 plus density times gravity times height 1 plus 1/2 rho velocity 1 squared equals pressure 2 plus density gravity height 2 plus 1/2 rho v squared 2. So in the figure, we can say that pressure 1 is given, and the height in the figure 1 is 0 because there is no height. It means that the tube is in the ground. So we can say that the height of the tube 1 is 0 plus 1/2 rho v1 squared. So in the right part here, the pressure is missing, and we know that the height of the tube B is 10 meter because tube B has a height because it lifts from ground to A or A to B. So we cannot say that this is 0 because it is given in the problem plus 1 half rho V squared. So we need to simplify it first. So we need to cancel what is need to cancel and try to figure this out. So we know that this row GH1 is cancelled because the height of this is 0. So multiply to the number times 0 is 0. So we can cancel this and we can cancel this one also because the velocity from tube A to tube B is still the same. So we can cancel because this part in the left side is also have here in the right side. So we can cancel this out. So the only left term is this pressure 1 equals pressure 2 plus rho GH2. So in this simplified form, we can now plug in the given to the formula. So pressure 1 is 150,000 pascals and equals to pressure 2, which is the missing one that we need to solve. And the density of the water, we know the density of the water is 1000 kilogram meter cube. And the gravity of the earth is 9.81 meter per second. And this height is 10 meter from ground to the point to B. So in this formula, we can solve the pressure 2 now. So if we plug in this into the calculator, the answer would be this 152,000 pascals. Or if we want to convert it to pascal, we just need to divide it by 1000 because 1000 pascals is equals to 1 kilopascal. So this is the answer in the letter B. So we answer all the problem and thank you for watching and God bless everyone.
Hello everyone, I'm Adrian Montibon, a student from University of Mindanao, and today I'm going to teach you step-by-step solution using Bernoulli's equation. Can you show me step-by-step solution in this problem? A pipe with a radius of 20 cm connected with another pipe with a radius of 10 cm. Both are in horizontal position. The velocity of the water flow in the large pipe is 2 meter per second at a pressure of 10 to the power of 5 Newton per meter squared. What is the water pressure in a small pipe? Assume the acceleration of water due to gravity is 10 meter per second squared, and the density of water is 1000 kilogram per meter cube. So we have here a pipe with a radius of 20 centimeter, and it is connected with another pipe with a radius of 10 centimeter. The velocity of the water flow here in the larger pipe is 2 meter per second, and it has a water pressure of 10 raised to 5 Newton per meter squared. So the question is, what is the pressure here in the smaller pipe? To solve the pressure in the smaller pipe, first we have to determine the velocity here in the smaller pipe. You can say that A1 times V1 is equals to A2 times V2. A2 is the cross-sectional area here in the smaller pipe, while A1 is the cross-sectional area here in the larger pipe. So therefore, V2 is equals to A1 times V1 over A2. This is equation 1. Now, to solve the area of the pipes, we will use the pi r squared, the area of the circle. So, notice that the radius is in centimeter while the other givens are in meters. So we should convert the centimeters to meters. So therefore, A1 is equals to pi times 20 centimeter times 1 meter over 100 centimeter squared. Cancel the centimeter. We can get pi times 0.04 meters. In the area of the smaller pipe, can get pi times 10 centimeter times 1 meter over 100 centimeter squared. We can get pi times 0.01 meters. This is equation 2 and this is equation 3. To get the velocity of the smaller pipe, we will substitute the equation 2 and 3 into the equation 1. So therefore, V2 is equals to pi times 0.04 meters times the velocity here in the large pipe, which is the 2 meter per second, over pi times 0.01 meters. Cancel the meters and cancel the pi. Can get 8 meters per second. So that's the velocity here in the smaller pipe.
Oh my God! Wow!
Now, we already got the velocity, so we can also solve now the pressure in the smaller pipe using the Bernoulli's equation. P, or pressure 1, plus the density times the gravity and height, plus 1/2 of the density times the volume squared, is equals to the pressure of the another pipe plus the density and the gravity and the height of the pipes, and also plus the 1/2 of the density times the volume squared. Since the pipes are in horizontal position and the height doesn't change, therefore we can cancel out the PGH1 and the PGH2 and simplify the equation to P1 plus 1/2 PV squared is equals to pressure 2 plus 1/2 times the density times the volume, velocity rather, squared. Solving the pressure of the smaller pipe, which is the P2. So we can get P1 plus 1/2 density times velocity of the smaller pipe, larger pipe rather, minus the 1/2 and then times the density and the velocity of the smaller pipe squared. So substituting this equation to the given values. So 10 raised to 5 plus, this is in Newton per meter squared or pascals, plus 1/2 times the density, which is the 1000 kilogram per meter cube, times the velocity, which is the 2 meter per second squared, minus 1/2 times the 1000 kilogram per meter cube times the velocity of the smaller pipe, which is the 8 meters per second squared. So this is 100,000 pascals plus 1/2 times 1000 rather kilogram per meter cube times 4 m squared over s squared minus the 1/2 of the smaller pipe times the 1000 kilograms per meter cube times 64 meter squared over second squared. So cancel the meter. Can get that 100,000 pascal plus 1/2 times 1000 kilogram per meter times the 4 over second squared minus 1/2 times 1000 kilogram per meter times 64 per second squared. So I can get 100,000 pascals plus 4,000 divided by 2, this is 2,000 kilogram per meter times second squared. This is already a pascal like this, so minus 64,000 divided by 2, which is 32,000. This is also pascals, so we should write it in pascals. So therefore, the final answer is 100,000 minus 32k rather. So the final answer is 70,000 pascals.
Oh my God! Wow!
I wonder how, I wonder why. Yesterday you told me about the blue, blue sky, and all that I can see is just a yellow lemon tree. I'm turning my head up and down. I'm turning, 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 turning around, and all that I can see is just another lemon tree. Sing that, da 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 da, dee da da, da 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 da, dee da da, da dee dee da. I'm sitting here, I miss the power. I'd like to go out, taking a shower, but there's a heavy cloud inside my head. I feel so tired, put myself into bed. Well, nothing ever happened.